solving equations with variables on both sides. If I were to have given you an equation like 4x plus 32 equals 6x plus 18, you might look at that and at first be like, I don't know where to go with this because I see x's on both sides. All the equations that we've worked with up to this point only had x's on one side of the equal sign. So we only saw x's to the left of the equal sign or to the right, but never on both. But in order to tackle this equation here, it's really just using the same idea as what we see in a mobile problem. So if we have this mobile problem here, the left side, the shapes on the left, balance or equal all the shapes on the right. So 4 squares and a heart have the same weight as 6 squares and a circle. I don't know what the square is, but I know that the heart is 32 and that the circle is 18. So in order to figure out the value of the square here, notice that we could remove extra squares in order to better see what a square itself is actually worth. I could take away a square from both sides because since they're the same weight, if I remove them from the mobile, everything will still be balanced. 3 squares and a heart will balance 5 squares in a circle. And so I could even take away 2 squares because from each side, because that would be equal weight. I could take away 3 squares from both sides. I could even take away 4 squares from both sides because I'm taking the same amount of weight off of each side of the mobile. So in doing so, that actually makes things easier for me. Now I can clearly see that 2 squares, so 2 squares, maybe I'll call that x. I'll call the square an x. So 2 x's and a circle, which is 18, is equal to a heart, which is 32. So notice here, 2 squares and the circle is the heart. So 2x plus 18 equals 32. So we could solve this equation to figure out that x is 7. So x is 7 here. So x is 7. This idea of taking away extra shapes from both sides of the mobile is essentially the same idea as when we work with an equation. When we look at this equation, 4x plus 32 equals 6x plus 18. I'll encourage you to write this down. Notice that there are more x's on the right side than there is on the left side. In fact, if we were to take away 4 x's from both sides, we would have no more x's on the left. On the right, we would still have 2 x's, 6x minus 4x is 2x, and then that 18. Hey, that's the same thing we had over here with our mobile because it's the same idea. We took away 4 squares from both sides. Here we just took away 4 x's from both sides. In doing so, now we have a 2-step equation that we can solve. 2x plus 18 equals 32. We can take away 18 from both sides. So 2x is 14. Dividing both sides by 2, we would get x is 7. So this idea of taking away the extra x's is really the heart of solving equations with variables on both sides. So if I were to summarize this in one sentence, to solve equations, which I'll abbreviate EQNS, with variables on both sides, and by that I mean both sides of the equal sign, we are going to add or subtract variables to end up with only one side having them. To solve equations with variables on both sides, add or subtract variables to end up with only one side having them. So we took away 4x from both sides here. So doing so, we eliminated the x's from the left side. We only had them left on the right side. Only one side had it left. So let's see a couple more examples. If I have the equation 9x minus 6 equals 3x plus 18. We have more x's on the left side than we do on the right side. In fact, we could take away 3 x's from both sides. And in doing so, we would no longer have them on the right. 3x minus x, 3x is 0. So I just have 18. But over on the left, 9x minus 3x is 6x. I still have 6 x's left. So 6x minus 6 equals 18. This is nice because now we have a two-step equation that we could solve. We could add 6 to both sides, working to isolate x. 6x is equal to 24, so dividing both sides by 6, x is equal to 4. X is equal to 4. So I subtracted 3x from both sides, and in doing so, I ended up with only having x's on the left side. Let's take a look at one more example. Negative 2x minus 7 is equal to 10x minus 14 minus 4x. So before we start taking away from both sides, first, when we look at the right side, just on the right side, notice that we have a 10x and a minus 4x. Those are on the same side of the equal sign. So if I were to combine those, 10x minus 4x gives me 6x. So 10x minus 4x is 6x minus 14. So I have negative 2x minus 7 equals 6x minus 14. Notice that we have 6 x's on the right and negative 2x on the left. So which side has more x's? 6x, the right, or negative 2x, the left? The right side has more x's. 6x is greater than negative 2x. So in fact, I could add 2 x's to both sides. And in doing so, negative 2x plus 2x, that would be eliminated. I only have negative 7 on the left. And on the right, 6x plus 2x gives me 8x minus 14. So I added 2 x's to both sides. So that way, in doing so, I ended up only having them on the right side. We can add 14 to both sides. Negative 7 plus 14 is positive 7. It's equal to 8x. Dividing both sides by 8, I just end up with the fraction. X is 7/8. That's fine.